All right, number 5. If g of x is even, find the depth integral from -6 to 3. Let me highlight the steps I want you to go through. First, you're going to start with your shorter interval. Start with graphing your shorter interval. And then you're going to use the even and odd or odd relationship for the other side. Get that taken care of. And then move on to resolving your larger interval. If you don't do it in this order, it just feels a little bit, you feel like you don't have a foundation to stand on, and it makes it a little harder to interpret. So I suggest that this, if you do it this way, things will just feel a little bit more structured. Okay. So even function. So we know we're going to be creating mirror images on both sides of our y-axis. Okay, where do we start? Short interval. But this is a little strange here. We got to be careful about what? Okay, what else? Something's a little bit off about this. They don't. Something else. Bounds. The bounds are what? They're backwards, right? This is not from left to right, so let's rewrite this so we can, so this is a bit more clear. Another way to rewrite this is what? Integral from 0 to 3 of g of x is what? 4. It's 4. So it's really a 4, even though it's showing -4. We see that, so we need to spend the time to rewrite it. So just be careful of that, right? So if something is not in the proper order, you can always put it into the proper order, just change the sign. Okay, let's start with this, right? So 0 to 3 is 4. So I've created what my shorter interval will look like. Let's don't do the larger interval first. Let's fill out the other side. So what can we do on the other side?
0, -3.
Is also what? 4. Okay, keep in mind, these are set in stone. Any overlap that occurs will have to be containing the other parts. Okay, we don't want to be overlapping this region. These are already finished. So now we can move on and say that, okay, I know that from -3 to 6 is equal to 10. So from -3 to 6 is equal to 10. I already have 8 accounted for. So I don't want to do this. I don't want to do this whole overlap and call it 10 because we already know this is done. We don't want to be putting area on top of what's already been established. So what remains then? If this is 8, then we know from 3 to 6, it must be what? It must be 2. And now it becomes more clear, right? Because if this is 2, then the other side is also what? 2. I know the whole area is going to be 14, or sorry, 12, but let's see, is it asking for the entire region? It's only asking for
3/4.
Yeah, only asking for from -6 to 3, so 10. You guys want to try part B? Follow the same process, but when you get to the second step, you're going to do equal but opposite. So whatever is showing on one side, you're going to create the opposite sign on the other side. Okay, so try part B, and then I'll step through it once you guys try it. What do you know from -3 to 0?
-4.
Yeah, -4. I know that each of these regions have to add up to be 10. So what's going to have to be between 3 and 6? Has to be 10, right? Because -4 plus 4 is 0. So I know that I got to add up to 10. So this must be 10. And if this is 10, then what the other side?
Negative.
Negative. What's the depth integral from 0 to 6? So if you follow this order that I've established, I think this is the most straightforward way to kind of building your graph. Okay, back. Oh, yeah. So -3 to 6 is 10. And then so therefore 0 to 6 will be 14.
For 6 is missing a bound.
Sorry, we're gonna skip number 6.
Oh.
That's just properties. Let's look at number 7. Okay, so first off, I want us to be able to look at this problem and realize there is no one rule that can handle this, right? This is too complicated for any one rule to handle. There's too much going on, which means that we got to go through your substitution. But it's kind of like a puzzle, right? It's like, well, what's the u value? Is the u value secant? Is it tangent? Is it one of the parentheses? Is it both the parentheses? And it almost requires us to kind of look ahead to see, okay, what rule are we trying to work towards? And maybe that can help us have an idea what our u value could be. So looking at this, what rule could we be targeting that we're trying to work towards? Yeah, secant tangent. And that kind of guides our effort a bit, right? What's our u value then? 3 over x, yeah. I know this looks strange here because it's like, well, how is this going to handle this x squared? But remember, everything is opposite with the denominator, right? So the denominator, when you go through power rule, it will produce that x squared in the denominator because of the negative exponent and the way that it works. So this is not going to be an issue because of the variable in the denominator. Okay, so we'll start there. We do want to go through power rule to find du dx, but it is not in the proper form. So let's bring that x up. Okay, what's our derivative?
3 over x squared.
Let me clean this up here with positive exponents. I'm going to cross multiply and eventually, oh, I forgot to underline. So my goal is this, right? My initial step is let me get these replaced and then I can step back and see what can be done. And the hope is that after everything cleans up, we can work towards this rule. Cross multiply here. So make sure that once all your coefficients and your variables cancel out, sorry, once our coefficients are outside, it should look exactly like the rule that you want to use, right? If there's even something off about the variables, we got to go back to our drawing board. We can't make a slight adjustment in our rule and all of a sudden it works, right? We're very restrictive with our integral rules. So the x squared, did the x squared cancel out?
Yeah.
Yes, but there's a coefficient of what?
Negative.
Negative 2/3. So once that negative 2/3 comes out, everything matches perfectly, right? That's how we know we have a rule to use. Perfect match. What's the rule for secant tangent? Secant. Okay. Remember, if you go through u substitution, your u variable is a temporary variable, right? Make sure you always bring back your original variable. Okay, number 8. Expansion, is that possible? Cannot expand. It's got to be a u substitution, right? But what's our u value going to be?
2 minus x.
Yeah, it helps to get that parentheses showing up. But do we foresee a potential issue up ahead? Yes, so the x's will not cancel out, but it's okay. We just have to go through another set of substitution called change of variable to get that x replaced, and then we can. Okay. So this x is causing us an issue. I see some students, they would move forward and just do power rule here, but we can't do, we don't have rules available to us unless the variable is resolved. So that x has to be replaced. So we look at what's available to us. We have u equals 2 minus x. What if I rearrange that equation and solve for x? So x equals what? 2 minus u. So this will go in place of this. Now, when we make that substitution, it's not going to automatically get us to where we want to be, but it will help us move in the right direction because our first goal is to get it down to one variable, and then we can clean up in necessary ways so that we can get it ready for power rule, and then we can do power rule at the end. Yeah, I'm going to just rewrite it one more time because I would just like to have something in front, just distribute everything through once rather than have to do 5 and the u and the negative at different times. So I'm just going to do it all in one go if I can. I'm still not ready for power rule, but I'm almost there. I'm going to just distribute this through. Once every term is nicely separated, then I can do power rule. Then I can do plus c. And then, oh, and then remember, u is only a temporary variable, so we need to bring our 2 minus x back into our answer eventually. Okay, eventually. And I'm just saving that U value for my replacement of X's that I need. I'm going to skip number 9, but let me just walk through the process here. What can we do? Because the balance is not going to play a role, right? How do we handle this problem here? Yeah, you want to expand power rule. So once you get all that taken care of, then you can work in the upper and lower bounds. Okay, so you guys have the key. It's not too bad. Let's look at number 10. Okay, we do see bounds, but we're going to pretend like we don't see the bounds, right? Because that's the last thing we look at. Now, tangent square, secant square, we don't have a rule that fits nicely there, but we know we got to go through U substitution. So if I want to go through U substitution, then I need to find the U value. I have two options here. It's either tangent or secant because I'm looking for a set of parentheses. What's a better fit?
Tangent.
Tangent, because we know tangent derivative of secant squared, that works out nicely. Whatever the derivative of this is gonna match with this leftover secant squared. And so there's my target. Make my substitutions. Do the x's go away?
Yes.
They do, right? So we know that's a perfect fit. This ends up being a nice clean power rule. U squared becomes U cubed. And I start plugging in the pi over 3 and 0 in for this.
No.
There's a mismatching variable, right? Either you get this in terms of x and then use the bounds, or you plug the bounds in for u, convert it in terms of u, then you can use this. But we don't want to mismatch the other two. So there's no third option here. So I'm going to, I think most students prefer bringing it back in terms of x, which is fine. Let's bring that x back. Now we're ready to use our bounds. Okay, you may be tempted to leave your answer like this, but this is not close enough. This is not right at the where I want it. Okay, we have to get it all the way down to a fractional value or a ratio value. Okay. So tangent of pi over 3. If you think about your unit circle here, pi over 3, your order pair is 1/2 root 3 over 2. So tangent is just y over x. Cover up the denominator there, y over x just root 3 over 1. Tangent of pi over 3 is just root 3. And tangent of 0 is going to be.
Just remember, top of my head, I don't have to show that word.
No, you don't have to. No. I'm just. Yeah. So just make sure you review your unit circles. Yeah. Now, if you want to leave your answer and simplify, that's fine. Okay. But you can't have any tangent or secant or sine left over in your depth integral problem. You have to get it down to a numeric value at least. So either of these are fine, just not this. You got to keep going from here. Okay, so we saw a little bit of power rule, use substitution. We saw definite integral. Arc of motion, you're just going from acceleration to velocity to position. Average value theorem, we did. Trig integrals, use sub, we did. Absolute value of definite integrals, drawing those triangles, so we need to review that. We good there? Okay. Second theorem, we did. Change of variable, we did. Even and odd, we did. Synthetic division, complete the square. We want to see that? Either of those. Okay, all right, let's do a synthetic division. Let's do complete the square. Okay. And then if we have time, we can also do an exponential. Okay, so hopefully that covers, a little bit of everything that you guys want to see.
Will there be an exponential problem like a to the u?
No, just e to the u. Yeah, so again, on the back page, I had you guys highlight those formulas, right? So I'm just focusing on the most basic formulas that I want you to know, because those are the ones with the highest chance of making it. And also the ones that will be testing you on. So just the basic ones, none of the more obscure ones. Okay, so let me just create one. If you guys just can grab a sheet of paper. Let's do a synthetic division. I got some scratch sheet up here too, if you want to grab one, or just. So we know we can't expand too many terms in the denominator. We know that use substitution is not going to be a good fit because the degrees are not favorable. Not our trig, because the gap is going to be for the denominator being higher than the numerator, right? Not the other way around. So this one is going to be synthetic division, because we do want to rewrite this problem in a way where we can produce an easier looking problem. So we start off by finding our critical point here, or our factor here. So x plus 1 equal to 0, which is -1. So you can put -1 outside your half box. We're just going to list out the coefficients, and if there's any skipped degrees, we got to make sure we have a placeholder. So we start off with x cubed. What's the coefficient there? 1. Next up is x squared. Do you see x squared?
No.
No. So I need to have a 0, a placeholder for x squared, followed by -2, followed by 4. Okay, drop the first number below. Multiply and add. Multiply and add. Multiply and add. We haven't solved the problem. We've just created an equation that will be easier to take the antiderivative than what we have here. Now we're doing dividing by x plus 1 here. So we're starting with x cubed, which means if I divide by x plus 1, we're going to be down to what? X squared. And once you have that first degree, then everything will just be will fall by 1. So x squared followed by 1x, followed by the constant, and followed by the what? Remainder. And the remainder, you write it as divide by x plus 1, because it can't go any further. So you're now going to do an integral of an easier problem. Your first few terms will just be power rule, and the last term is just going to be a baby u substitution, where your u value is a denominator, ends up being a 1/u problem, which is natural log. Okay.
I can just go straight to that.
Yeah, you can. You want to go straight to it, you can. Or if you feel more comfortable working out your u substitution steps, you can. It's up to you. Okay, let's try another one here. Are we okay here? Okay. All right, let's do this one here. 3x squared over x to the fourth minus 4x squared plus 19. Let's go down our checklist here. Power rule, expansion power rule is not going to work. Too many terms. Use substitution is not going to work. It's not synthetic division. So what option do we have left? Our trig, right? You see there's a nice gap relationship here with the denominator being a higher degree. So we know that we can work with arc trig. So we know it's going to be arctangent, and we do have to get that denominator cleaned up because we do eventually want it to look like this. So I do need to spend time factoring and complete the square for that denominator portion. So x to the fourth minus 4x squared plus space. My formula is b over 2 squared. So what goes in these spaces here? My b value is 4, so 4 over 2 is 2. 2 squared is 4. We can go through factoring. Multiplies to be 4, adds up to be negative 4. Sorry, I realized I made a mistake here. This should be just 3x. It won't work. It just. Okay, so here's my cleaned up version here. I'm going to get ready for my a value here. So that 15 is not quite suitable for what I want to pull. So what can I put inside that parentheses? Square root of 15. Okay. So we have our a value being root 15. We have our u value is x squared minus 2. du dx is 2x. dx equals du over 2x. We make all of our substitutions. Cancel out the x's, hold the coefficient out in front, and now it should look exactly like the rule that we want to use.
Why use so?
I'm sorry?
After completing the square, why use so?
Because we still have to convert every x in terms of u, because this is the rule that we want to use.
Oh,
right. Okay, perfect match with the arctangent rule that we want to use. So we start off with our coefficient. 1 over a, my a value is root 15. Arctangent of u over a. No need to rationalize the denominator. Root 15 is fine. And then plus c. I didn't have time to do an exponential e to the u problem, but this is off of worksheet 3. And with this one, this matches nicely with e to the u. So our u value is 3 over x. We get that cleaned up, find the derivative, and we're able to get the x squared to cancel out. When the x squared cancels out, we have e to the u. E to the u is a nice, easy rule because the integral of e to the u is just e to the u. Bring your u back in terms of x if you want, or convert your bound in terms of u, and then you plug in your upper and lower bound. You can leave your answer in terms of e, because you're on the calculator. Oh, whatever I converted the bounds, that's why it's like there in terms of u. So whatever your lower bound ends up, you're going to keep at your lower bound. If there's a sudden swap, you keep it that way as well. Now, if you want to switch it, you can. But if you switch it, you got to pull another negative sign out. So
It's still fine.
it's still fine, yeah. I think the only time you want to adjust the bounds, so is when you're reading a graph and you prefer to do from left to right. But if it's a first theorem problem, the out of order will work itself out. All right, help session this afternoon and tomorrow. I'll go over any class problems that you want me to go over, but really I'm just highlighting these problems. All right, come get your phones. If you want to take a picture of this, this will kind of help you make sure that you can check those off your list once you're comfortable with those topics.
Sorry, this is tomorrow.
All right,
Sorry, this is tomorrow.
that's tomorrow. That's tomorrow.
Okay, good.
Great, thank you.
It's the arch, it's the good thing, the square.
Yes, yes, yeah. So they'll go hand in hand.
We might need to throw up a.
Yeah.
We have to give them this, going.
She's.
How are you? All day drinking.
It's like, it's the one, so.